Hello, today what we're going to do is we are going to start factoring things by undoing the distributive property. So to start us off, we're going to start by distributing x plus 3 to 2x minus 7. So we would take x and we would multiply by 2x and we would get 2x squared. We would do x times negative 7 to get negative 7x. 3 times 2x would give us 6x. And 3 times negative 7 is going to give us negative 21. Then what we would do is we would combine like terms. So we would get 2x squared minus 1x minus 21. So this would be the distributed form of those two factors. So today our goal is I'm going to give you an equation that looks like this, the 2x squared minus x minus 21. And I'm going to say go backwards. Find the two things that multiplied to get that. So in order to go backwards, what we need to do is we need to undo this process here. So we have to first kind of break apart the middle term so that we can then figure out what was distributed. So this brings us to what we did yesterday. So if you have not done yesterday first, stop and go back to that so that this makes sense. So your A value for this one is going to be 1. Your B value is going to be negative 1. Sorry, your A value is 2. Your B value is negative 1, and your C value was negative 21. Yesterday we learned that we want to figure out what multiplies to get A times C, which in this case is negative 42, and adds to get B, which in this case is negative 1. And if we think through those numbers, we're going to come up with 7 and 6, and the 7 has to be negative to make it add to negative 1, but yet multiply to get negative 42. So then yesterday what we did is we rewrote the first term, we broke up the second term into our two expressions, minus 7x and plus 6x, those numbers that we just got, and then we left the minus 21 alone. So that's what we did yesterday. Today we're going to take this one step further. Because if you look at the process above, 2x squared minus x minus 21, that's what we ended with. The in-between step was that distributed property there. So we actually have this in-between step here. We today are going to take it that one last step to figure out what was multiplied to get that in the first place. So here's how we do it. Step 1, identify your A, B, and C value. So nothing new yet. Step 2, look for your number pairs. So again, nothing new here. We're going to multiply A times C. So we're looking for what multiplies to get negative 60 and adds to get 4. So 1 and 60, 2 and 30, 3 and 20, 4 and 10, nope, 6 and 10. There we go. That's the one we want, 6 and 10. And if it has to multiply to get a negative, one of these is negative, which gives us the 4 overall. Step 3, split the middle term. Again, not new. So we have x squared minus 6x plus 10x minus 60. And it can go in any order. Okay, it doesn't matter which order as long as you keep the first term and the last term. The middle two can get flip-flopped. So here is the new part. Okay, so I'm just going to rewrite my problem one more time. X squared minus 6x plus 10x minus 60. Here's what we're going to do. We're going to cut this exactly in half. So we have two terms on the front and two terms after that. We're going to look at these and we are going to find the GCF of the first two terms only. So x squared and 6x, the GCF here is x. So what I'm going to do is I'm going to divide each of these by x, and I'm going to factor that x out in front. So the GCF goes in front, and we figure out what's left behind when we pull the GCF out. So if I divide by an x, I have x minus 6. For the last two, I do the same thing. My GCF here for 10x and negative 60 is going to be 10. So what I'm going to do is I'm going to put my GCF out in front. My GCF was positive 10. And I'm going to divide just these two terms by 10. When I do that, I get x minus 6. Now, this is very important. This right here has to happen. So right here, I don't know, put a big star or something. These two things have to match, the x minus 6. What that tells us is that one of our factors is x minus 6. The other factor is going to be the coefficients here, so x plus 10. So you can write these in any order. You can do x plus 10 and x minus 6 as long as both of your factors are there. Now, the very nice thing about factoring is you can always check your answer. So we are claiming that if you take this and you break it apart, you get x minus 6 and x plus 10. Well, let's check it, okay? You can always check your answer because you can use your distributive property just like our first example in our warm-up. We get x squared plus 10x minus 6x minus 60. So if we were to distribute this, we get x squared minus 4x, or plus 4x minus 60. That's what we started with. So we did the right thing. So let's try another one here. Okay, so we're going to factor this by splitting the middle term. So for this one, we're looking for what multiplies to get a times c, which in this case is negative 10, but yet adds to get negative 9. So you think through your number pairs, 1 and 10 are going to be they're going to have to be the ones, and the 10 has to be the negative one. So I'm going to split my middle term like we did yesterday, 2x squared plus 1x minus 10x minus 5. Here's the new bit. Again, we're cutting this exactly in half. We're looking at what do the first two terms have in common. And for these first two terms, they only have an x in common. If I divide each term by that x, I would be left with 2x for my first term, and x divided by x just becomes 1. My next two terms, be careful here, we have a negative 10x and a negative 5. Since it starts with a negative, my GCF here is actually going to be negative 5. When you find your GCF, then what we're going to do is we are going to divide each term by negative 5, and we're going to write that GCF out in front. So negative 10x divided by negative 5 is 2, and then x. Negative 5 divided by negative 5 becomes a positive 1. Here's how we know this is working. 2x plus 1, that is the same. So 2x plus 1 is one of my factors. And then my other factor comes from the other numbers that are out in front. So it's going to be x minus 5. And let's just do a real quick check here. We don't have to do too much with it. Distributing, you get 2x squared minus 10x plus 1x minus 5. And these middle two would combine to get us exactly what we started with originally. So we're doing it right. So let's go ahead and try a couple more together, and then you can have some time to work individually. So here we go. For our example number 1 here, we're going to figure out what multiplies. Our a value is 1 and c is negative 6. So we're looking for what multiplies to get negative 6, but adds to get our b value of negative 1. So it's going to be 3 and 2, and the 3 has to be a negative. So we rewrite this as x squared minus 3x plus 2x minus 6. We chop this in half. The first two terms have a GCF of x. So we're going to divide each term by x, and we get x minus 3. The next two terms have a GCF of 2. And when we divide each term by 2, we are left with x minus 3. Our two factors are the same, which means x minus 3 is one of my factors, and then x plus 2 would be my other factor. And then to check it real quick here, we get x squared plus 2x minus 3x minus 6, and combining like terms gives us exactly what we started with. Let's try this next one. Now we have this 12 out in front, so let's see how that changes things. We're looking for what multiplies to get 12 times 3, or 36. And we're looking for what adds to get negative 13. So you might have to go through some number pairs: 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So the only things that could work are the 4 and the 9 if they were both negative. So we get 12x squared minus 4x minus 9x plus 3. And we're going to chop this in half. Be careful because that negative sign has to stay with the 9. The first two terms, we look for the GCF of only those two terms. 12 and 4 have a 4 in common, and for the x's, there is one x in common. So we're going to divide out 4x. So we have 3x minus, now x divided by x cancels out, and 4 divided by 4 also cancels out, but 4 divided by 4 is actually 1. So don't just kind of cancel it and forget about it. You do need that 1 as a placeholder. Now the next two, we have 9x and 3. So the GCF is going to be 3, but because the 9 is negative, you do need to divide by negative 3. So we're going to divide each of those two by negative 3. And so we're going to be left with a positive 3x and a negative 1 once you divide positive 3 by negative 3. Now you'll notice that the 3x minus 1s are in both of those, so they're one factor. And then the 4x minus 3 would be our other factor. To do a quick check, when we multiply, we would get 12x squared minus 9x minus 4x plus 3. And that is exactly what we started with when we combined the middle two. Okay, let's go ahead and do two more. We're going to do example 3, and then we're going to skip to example 5. So let's go ahead and start this one off. We're looking for what multiplies to get 15, but yet adds to get 8. So thinking through our numbers, that's going to be 3 and 5. And so looking at this, I'm going to do 3x squared plus 5x plus 3x plus 5. So I split up my middle term. I'm going to look for my GCF of the first two. They have an x in common, so I'm going to take that out. I have x out in front, and then 3x plus 5 in parentheses. And now we run into a problem because the GCF of the second two, well, 3x and 5 have nothing in common. When that's the case, we're going to say our GCF is 1. Okay, so if these have nothing in common, take out a 1. So 3x divided by 1 stays 3x, and 5 divided by 1 stays 5. And by factoring out this 1, we can see that 3x plus 5 is our factor, and then we would need to have x plus 1 as our other factor in order to make that work. Okay, our last one, we're going to jump to example 5, and we're going to look at this one because our b term is missing. So if you don't see that x there, that means b is 0, because a is in front of x squared and c is your constant. So for this one, we're looking for what multiplies to get 4 times negative 9, or 36, and what adds to get 0. That's the weirdest part about this. So it's going to have to be 6 and negative 6. So you can write those in any order and then keep up with the grouping. So split it in half. The first two have a 2x in common. The last two have a 3. And then therefore, you get 2x minus 3 and 2x plus 3. Thank you for listening.